Hi everyone, today we're gonna explore the LangChain Expression Language, the backbone of the LangChain framework. Many people told me they struggle to understand how it works, and the poll last month on my channel showed the same. In this video you will learn how LangChain does its special piping syntax under the hood. We will create our own class with the typical LCEL syntax with pipes. This will give you the basic understanding of how LangChain achieves this kind of magic. After that we will explore the most important runnable classes, RunnablePassThrough, RunnableLambda and RunnableParallel, which allow you to create 99% of chains you may need. As always, you will find the code in the description. Okay, I'm currently in VS Code, and let's first start with the basics. We will create a very simple chain before we dive into the details of the implementation. So our first chain consists of a model, a prompt template and an output parser. We also load the OpenAI API key from our .env file. Okay, so we will first create instances of these classes. So we create an instance of the chat prompt template with the from template method, and here we pass in a single variable which is topic. Then we create an instance of the chat OpenAI class and also the output parser. Now the most important step, we compose our chain, and we do that with the pipe operator. So that's the LCEL syntax, and that syntax is heavily inspired by the Linux terminal and shows the data flow. So we first pass the variables here, which we run in the invoke method. We pass that to the prompt template, that gets passed to the model, and that output gets again passed to the output parser. And this is how it works, so from left to right. So if we run invoke, we can see that the dictionary we pass here matches the variable name in our chat prompt template, and then from this we will receive a final answer. So tell me a joke about a topic. We want to say ice cream. Why did the ice cream truck break down? It had too many scoops. Okay, that was the joke. And now what's actually going on under the hood? So we've got this invoke method not only in our model or in our prompt, but we have it in every single part of our chain. So every class of our chain implements the Runnable Interface from LangChain, and each of the classes have got an invoke method. So first, let's maybe try that out. Here we take our prompt and run the invoke method there. So here we pass in topic ice cream. And if we have a look at that, we can see that the output is a messages object. And here we've got a list of a human message. Content is tell me a joke about ice cream. So that's the result. And now this gets automatically passed to the next step in our chain. So the output gets passed to the model. And now if we take that and create our own variable here, we can run the invoke method with our model. And this will return an AI message. And now we can take that again and pass it to the output parser. And this will then at the end create this string. Okay, so that was a very simple example, but like I said, this is the magic of the LangChain expression language, this simple operator. So what is this operator actually? That's the OR operator, which is defined by the __OR or the __ROR method. And we can in Python overload this. So normally you use it like this. So you do comparison like this. So is 2 or 3 larger than 3? And this will result in a false. If you do this like this, is 2 or 3 larger than 1, then you get a true. So one or the other has to be larger than this to make the whole operation true. So that's the standard behavior. But like I said, in Python you can overload methods, and this is exactly what LangChain does. So first we create our own LangChain expression language, and to do this we will create a class called cRunnable, so inspired by Runnable class from LangChain. I call it cRunnable because it's our custom Runnable class. This custom Runnable class has a single attribute, which is none at the start. And we've got two methods, an abstract method, which is the private interface. So we have to override this when we inherit from this custom Runnable class. And then we've got our invoke method. And what actually happens here is that this invoke method calls the process method, where we pass in some data. So this is how the data processing is done under the hood. And then we've got the invoke method. This is the public interface of our class. So what happens here is we pass in some data, like here above, where we pass in topic and ice cream. So this is where we publicly pass the data. This gets passed to the process method, and the processed data gets passed again to this next attribute. And as you can see, an invoke method is called on that next attribute. So this is again a cRunnable class. And how can we actually achieve this? This can be done with the overloading of the OR operator. So instead of achieving this behavior, we can also return a new class from this operator. So if this would be the same, like here, we could say that if we run the OR operator on a 2, we then would return another number. So we actually could do this if we want to. But here, we actually do this. So we return a new class, the runnable sequence class, which we implement here. And to this runnable sequence class, we pass to the constructor 2 arguments, so first and second. And the first one is self. So we pass this cRunnable object to the constructor of the cRunnable sequence, and then we pass another runnable. So we've got in this runnable sequence class 2 cRunnables. And this is how we can achieve this logic. So this is actually done here in the invoke method. So first we call the invoke method of our first cRunnable, where we pass in the data with the invoke method. So this is the first result. And then we run it a second time. And because this is a runnable 2, we can also run the invoke method of that second object, where we pass in the result of the invoke method of our first cRunnable. And this is how we achieve that data is passed from one object to another. So let's actually run this. And now let's actually implement our cRunnables. Like before, like I said, we have this method, this abstract method, which we have to implement. So we define the process method here, which under the hood will be called by the invoke method. And the first runnable only adds 10. So we pass in data and we will add 10 to that. So the second one is multiplied by 2, where we pass in data and the data gets multiplied by 2. The third one is convert to string, where we just pass and make this a string and also make this an f string. Here result is data. So very simple, but these classes all implement this process. So we have the same interface. So then we create our instances A, B, and C, and we create our chain from that. So we do it like the real LangChain expression language here with this pipe operator. So we've got our chain, and then we can run the invoke method where we only pass 10. And now what happens is the first one is A, and here we add 10. Then we pass the result to B, and then we multiply the result by 2, and then we pass that to C, and this will be converted to a string. So here we can see it in the print statement. Add 10, then multiply by 2, convert to string, and this is the final result. Okay, great. I hope you now got an understanding of how the LangChain expression language works under the hood. This is, in my opinion, very important to really understand their behavior. And I think with these basics, we can now check out the runnables from LangChain. Like I said, we've got 3 very important runnables, which are RunnablePassThrough, RunnableLambda, and RunnableParallel. These are the most important runnables that you will use. The first runnable we're gonna explore is the RunnablePassThrough. And like the name suggests, the RunnablePassThrough does not do anything with the data. So we've got 3 RunnablePassThrough instances here in a chain. Here you can see the pipe operator. And if you run the invoke method of this chain, nothing really surprising happens. So we've got the same output as the input. So you may ask, why do I actually need this? And the RunnablePassThrough is very important if you use it in combination with a more complex input and other runnables like the RunnableLambda. And we're going to explore that in a little bit. The next runnable we're going to explore is the RunnableLambda. So sometimes you just want to run custom functions. And to do this, you need to wrap that custom function into a RunnableLambda. So because this normal function does not share the Runnable Interface and has no invoke method. But the RunnableLambda exactly provides that. So we just pass in a function to that RunnableLambda, and here the input gets now converted to whatever we want to. So in this example, we've got a string which gets passed from here to this runnable, and then the input to upper method is run. And then the output is again passed to the next RunnablePassThrough. So what happens here is we convert the string to uppercase and then return that output. And if you run that, we can now see that the hello is now in uppercase. Okay, so now let's explore the RunnableParallel. I think that's the most important and most useful runnable. The RunnableParallel is there for running tasks in parallel, but don't really think of running that in parallel like in multiple threads, but more like doing two tasks with the same input. The most common use case is to branch away from the input data and perform some data transformation on one branch and leave the other branch untouched. So we start with a very basic example. So we've got this RunnableParallel and we provide a dictionary here, and here we've got a RunnablePassThrough. So if we run the invoke method on that, you can see that the output will be the following. So let's run that. And now you can see we've got a dictionary. So this is created by this RunnableParallel. So we've got branch X and branch Y, and RunnablePassThrough is there for keeping this data unchanged. So maybe we only want to perform the uppercase method on this branch Y, then we could create another chain inside here. So, but since we've got a RunnablePassThrough, this now keeps unchanged, but we created this dictionary from this original string. So now let's maybe create another example. So this is what you often see, that we've got two inputs, and normally you provide that as a dictionary. So the input here is hello and the input 2 is goodbye. Now try to think of how this looks like. So as I said, this RunnableParallel will create this key, and RunnablePassThrough will not change the data. So this will be the value for X and also for Y. So this is how it looks like. Here we've got X and this is the value, and that's not changed because this is the RunnablePassThrough. And the same applies for Y. We can also do something like this. So we provide a RunnableParallel, and for the X we provide this RunnablePassThrough, but for Y we have got a lambda function, and here we only extract input 2. So the first very important step is that actually this will not work, because now we rely on this input 2 key. So let's run it, and here we can now see that we've got a key error because we don't have that input 2 key. If we run that with the correct key, we can now see the difference in comparison before. Here we've got X, this is the same like before, but for Y we now extract the input key, which is goodbye. Okay, so this is what you can also do. You can run custom lambda functions, but after that you cannot pass the output here again to a runnable, because yeah, that's not runnable. If you want to do that, then you need to have a RunnableLambda. Okay, now since we covered the basics, we can now have a look at more complicated nested chains. So first we create a little function called find keys to uppercase. So we want to get a dictionary. So we now work with dictionaries, and we want to get the input key, and if that's not found, then we want to return a string not found, and we want to convert that to uppercase. So very simple function. And now we want to create a new chain. So we've got again this X key, and we've got this RunnablePassThrough, but now we nest this again. So we've got inside this RunnableParallel another chain. So we pass the RunnablePassThrough to the RunnableLambda, and here we run find keys to uppercase. So this relies on a dictionary, and then we've got again the example from before, just this simple lambda function. And now if you run this chain, as you can see, we've got input, this matches the key here, then we get the following. So X is now hello because we run that to the RunnableLambda, and we extract the input and convert that to uppercase. And for Y, we extract the input 2 key, and this is the same like before. So this is also goodbye. If we now have got an input that's wrong, so we don't have an input key, but we got an input 3 key, this will now not return or result in an error, but return this not found, because this is what we return as alternative. If the key is not found, convert that to uppercase and return that from this RunnableLambda. So this is why we get not found here. Okay, so now let's explore how we can add keys on the fly, and we can do that with the assign method of runnables. So first we create a very simple chain. We got a RunnableParallel, and here we've got a dictionary with an X key and just a RunnablePassThrough. We also got two functions, the assign func, which just returns 100, and then the multiply function, which just multiplies the input by 10. So nothing really fancy. So first you can ignore that. And the first one is this chain. So what we have here is we run it with input and input 2, and I guess not very hard to guess now. This returns an X, which is the key, and the RunnablePassThrough is just assigned to as value here to that key, because the value does not change. But we can work with that and use now the assign function to add different keys to that. So the assign function allows adding keys. So we've got this runnable, and we can not just run the invoke method on that, but we can also run the assign method on that. So this will not run the function or not run the chain, but actually assign a new value when we invoke the chain. So what we're going to do is we create an extra key called extra, and that is a RunnableLambda with the assign func. So the assign func only returns a value of 100. So if you run that, our chain now looks like as follows. So we can see this is unchanged, but we've got this extra key and the value is 100. That's the output of the assign function. Okay, now let's have a look at how we can compose multiple chains together to a more complex chain. So we've got this chain and we combine it with another chain. So first let's create our new chain, and this chain is also very simple. So we've got this extractor function which takes in a dictionary, and we want to extract the extra key. So this works in combination with the output of that chain. So we've got that key, and then we've got our RunnableLambda which will run that function and pass the output to the upper or C upper method, and this will only get a string and convert that to uppercase, because yeah, this will not be a dictionary anymore. This will only extract the value and this will return a string. So we pass in a string to the output of that runnable. So let's try that. We pass in extra and test. And as you can see, this is uppercase. If we pass in extra 2, we can see that we get key not found. And now let's combine that. So we just do another pipe here. So we've got our initial chain, pass that to our new chain, and if we have now input and input 2, then what happens is we get just 100. So if that output surprises you, again, let's have a look at how this works step by step. So we've got our first chain, and if we invoke that, then we've got this dictionary as output here with X, and this another dictionary with a key input and input 2. And then we assigned here this extra key with a value of 100. And in this new chain, we actually just ignore everything which we provide as input. We only extract what we assigned here. So it doesn't really matter what we do here. We can assign in another key, do this like input 4, and this will always be the same. So that's of course not a very useful chain, but I think these weird examples help to create a deeper understanding of the LangChain expression language. So now we covered, I think, 99% of what you need, and now let's have a look at a real world example. And I think after going through the chains I just showed you step by step, this will be now much easier to understand. So this is a rag chain, and this takes in a retriever, and we pipe that to a format docs function. And we've got a question which is only a RunnablePassThrough, so this will be assigned to question. And then we take the output here, so this will be a dictionary, and pass that to a prompt. And the output will be passed to a chat OpenAI model, and the output of that will be passed to an output parser. So let's run it. We will first create a vector store and make that a retriever. Here is our template with context and question. And then we run the invoke method and again walk through that step by step. So as you can see, we provide a single string. What do cats like to eat? And the result is tuna. So how does this work? Let's again walk through that step by step. So we run the invoke method of that rag chain with a string input. So what do cats like to eat? And as you can see in our template, we need two variables, context and question. So we somehow have to convert that string to a dictionary. So we branch off with RunnableParallel. So this is actually a RunnableParallel here. This is done under the hood, but you can of course make that explicit. Yeah, this is how that works. So we've got a RunnableParallel, and as context, we pass the retriever. And this will, under the hood, call the invoke method of the retriever, and the output of that will be a list of documents and our format. Documents will now extract the documents from LangChain and extract only the page content and create a new line from that. So you always have to know the output of one part of the chain to pass the correct values to the custom function here. So that's very important. You always need to know how the output of one chain looks like. So now we've got our context and we've got the question. This will be unchanged. So this is the string we pass here, but this will be a list of documents, or better said, a list of strings here with a new line. And now with the RunnableParallel, we created a dictionary, and this is the expected data format that our template needs, because the template has got two variables, context and question. And if we actually would change it here, then our whole chain would not work any longer. As you can see, this now results in a key error because we always have to make sure that the keys match. So let's fix that. And now our chain works again. So we've got our prompt, and now it gets very easy. We pass that to chat OpenAI and pass that to the output parser. Okay, that's it. If you've got any questions about the LangChain expression language, let me know that in the comments. Thank you very much for watching. See you. Bye bye.